So this is 5.3/5.6, some applications of the definite integral. This section is long, so it's going to take me like at least 3, maybe 4 videos to get everything in. So I'm just letting you know ahead of time because you'll need some time to spend on this one. So the total area between curve and the x-axis. So if f of x is continuous on the interval from a to b, then the total area A bounded by f of x and the x-axis from x equals a to x equals b is given by 1. If the function is greater than 0, meaning if it's above the x-axis on that interval from a to b, then we just take and say that area equals the integration from a to b of the function dx. If f of x is less than or equal to 0, meaning that it's below the x-axis on the interval from a to b, then remember area can be taken, but we need to make sure that we have a negative sign out front of the integration of a to b of f of x dx. So again, if it's above the x-axis, you don't have to do anything special, but if it's below, remember that you have to have a negative sign in front of the integration sign. So let's look at example number 1. Find the total area bounded by f of x and the x-axis on the indicated interval. Make a sketch. Okay, so the function is sine. So if I draw a sine, I know that there's 4 key points. Pi over 2, pi, 3 pi over 2, and 2 pi. In this particular case, it's telling me that it's bounded from 0 to pi. So if I draw just that piece of it, I get this, this, and that. Okay, so I have a curve here, and if I'm taking the area under the curve, I'm looking for in here. So I'm looking for this. We see that it's above the x-axis. So if it's above the x-axis, I just take and integrate from 0 to pi. So that's my lower to upper limits. I'm integrating sine x dx. Okay? We don't have to do any integration because this function is pretty straightforward. So when you integrate this, the integration of sine x is negative cosine x. And I'm integrating that from 0 to pi. So now I have to find f at b and f of a. So f at b, remember that b is the upper limit, so x equals pi. So negative cosine at pi. Okay, cosine at pi is negative 1. So this becomes 1. And f at a, x equals 0. So negative cosine at 0. So cosine at 0 is 1. So this becomes negative 1. So now my last step is to take f at b minus f at a. So this becomes 1 minus a negative 1, which is 2. So the area under that curve, the total area is 2. So let's look at 1b. We have the sine function again, and if we sketch it, this time around though, I'm going from 0 to 2 pi. So here's pi over 2, here's pi, here's 3 pi over 2, and here's 2 pi. So again, we're going from 1 to negative 1, and this is the actual parent function of sine. So what I'm going to do is draw this in, and when you draw it, you can see that there are 2 areas. Area 1, which we just found, and then area 2, which is below the x-axis. So 2 areas. So what we're going to do is find the area of both regions. Okay, so just for clarity, I'm going to call this region number 1, and this is region number 2. So the area of region number 1, we just found in part A, it's 2. So I'm going to hold that there. But now I'm going to work on region 2. If I'm going to integrate it, I'm going to write up what I see. I'm integrating from pi to 2 pi. And because that area is underneath the curve, I'm making sure I'm putting a negative sign hanging out there. And I'm going to integrate sine x. Okay, so now it's time to integrate it. Don't forget the negative. Remember that sine is negative cosine x. And I'm integrating this from pi to 2 pi. Okay, so region 2, this is, I'm basically taking cosine x, integrating it from pi to 2 pi. So let's find f at b. That is when x equals 2 pi. So cosine at 2 pi equals 1. F at a is when x equals pi. So cosine at pi equals negative 1. So f at b minus f at a equals 1 minus a negative 1, which also equals 2. Okay, so the total area, I have to add the two regions together. So 2 plus 2 equals 4. So the total area is 4. So guys, I just want you to be careful with these because, or to think about it actually, not be careful, but think about it. If it's a sinusoidal graph, you have symmetry, right? So it makes sense that the area underneath the curve and the area on top of the curve should be the same. So this makes sense. So let's go ahead and do 1c. So 1c says the function is x squared minus 1, and we're going to map that from 0 to 3. So guys, what I'm going to do is I'm going to plot points, just so my graph, I can tell what's going on with it. So I'm starting out with 0, and if I plug in 0, I get negative 1. So 0, negative 1 is right here. If I plug in 1, I get 1 squared minus 1, which is 0. If I plug in x equals 2, 2 squared is 4 minus 1, which is 3. And then finally, if I plug in 3, I get 3 squared minus 1, so that's 8. So it's going to be up here. And I'm just going to put a little note that this is 8 up here. So this is what my graph looks like, right? Some of it's below the curve, some of it's above the curve. Okay. So the area below the curve, and let me get this to be smaller, is going to be right here. And the area above the curve is going to be this. All right, so let me just highlight it for you so you can see it. Okay. All right, so again, we have two regions, and we are going to have to find the integration to both. So the yellow I'm going to call region 1, and this guy will be region 2. Okay, so let's look at the first region. Okay, so I'm integrating from 0 to 1 of the function x squared minus 1 dx. Okay? All right, so this becomes 1/3 x cubed when you integrate it minus x. And I'm going to integrate that from 0 to 1. Okay? So I'm going to look at f at b. Remember, that's the upper one, so x equals 1. So 1/3 times 1 cubed minus 1. This becomes 1/3 minus 1, which equals 2/3, negative 2/3. Okay? F at a, x equals 0. So 1/3 times 0 cubed minus 1 equals negative 1. So now I have to take f at b minus f at a. So negative 2/3 minus a negative 1. So this is negative 2/3 plus 3/3, which equals 1/3. So this is region 1. Okay, so I'm going to put a little note, and I'll just make it yellow to correspond to it. It's region 1. Okay, this is region 1. All right, so region 1's done. Region 2. I'm integrating from 1 to 3, same function, x squared minus 1 dx. When I integrate this, I get 1/3 x cubed minus x, and I'm integrating this from 1 to 3. Okay? So f at b, x equals 3. So I get 1/3 times 3 cubed minus 3. Okay? So 3 cubed is 27. 27 divided by 3 is 9. And 9 minus 3 gives me 6. F at a, x equals 1. And I already did this, but just for giggles, I'm going to do it again. So 1/3 times 1 cubed minus 1. This is 1/3 minus 3 over 3, which is negative 2/3. Okay, so if I take f at b minus f at a, I get 6 minus 2/3. Finding a common denominator, I get 18/3 minus 2/3, which equals 16/3. And that is my answer for the second region. But I am not done. My last step is I've got to add these two together. So add region 1 plus region 2. Okay, so 1/3 plus 16/3 equals 17/3. And that is the total region. Okay, I'm going to stop the video here, and I'm going to do part 2 and pick up with the second objective.